So far we have looked at vector operations like vector sum, subtracting a vector from another vector and product of vectors. In this lecture, we are going to look at how symbolically write in a very compact way, and I am going to introduce something called the delta function. And Levi-Civita symbol. This I am going to denote as delta I j, and this I am going to denote as I j k, where I, j or k vary over 1, 2 and 3. That means, I could take values 1, 2 or 3, j could take values 1, 2 and 3 and so on. So, any subscript that I use here can take values 1, 2 and 3, and we are going to denote 1, we are going to use 1 for x coordinate, 2 for y coordinate and 3 for z coordinate. So, just to make you familiar, for example, I am going to write a x for a vector as a 1, a y as a 2 and a z as a 3. Writing in terms of 1, 2 and 3 makes life easy when we want to express quantities in a compact form. So, for example, vector a then could be written as summation I a I e I, where e I is unit vector in ith direction. So, you can see that if I expand it, it will be summation I varies from 1, 2, 3, a I, e I, and that becomes a 1, e 1 plus a 2, e 2 plus a 3, e 3, which when translated into our regular language of x, y and z, it will become a x I plus a y j plus a z k. So, this is just getting used to it, that I am going to denote x as 1, I am repeating it, y as 2 and z as 3, and any symbol subscript I, j, k, l, m, all of these vary over 1, 2 and 3. So, let me now introduce the delta symbol and Levi-Civita symbol. First, the delta symbol. Delta I j is going to be defined as, it is going to be 1 if I equals j. That means, delta 1 1 is 1, delta 1 2 we will see, delta 1 3 we will see what it is, delta 2 2 is 1, delta 3 3 is 1, delta 2 3, delta 2 1 and delta 3 1, delta 3 2. So, this part we have taken care of by writing delta 1 1 equals 1, delta 2 2 equals 1, delta 3 3 equals 1, and if delta I j is equal to 0 if I is not equal to j, and therefore, all these terms are going to be 0. If I were to represent this delta symbol as a matrix, it is going to be 1 0 0 0 1 0 0 0 1. This is delta matrix, if you like. So, this is an identity matrix. How does it help? Let us look at that now. So, if I take A dot B, recall from earlier exercises or earlier lectures that this is nothing but A x B x plus A y B y plus A z B z, which I can write as A 1 B 1 in our new notation plus A 2 B 2 plus A 3 B 3, which I can also write as summation I A I B I. And in terms of delta symbol, I can write this as summation over I, summation over j, delta I j A I B j. So, this is A dot B. You can very easily see that it actually is the same thing as A x B x plus A y B y plus A z B z. Let us do that just to get more familiar with it. So, I will have summation over j delta 1 j A 1 B j plus I is 2. So, that is going to be summation over j delta 2 j A 2 B j plus summation over j I equals 3 delta 3 j A 3 B j. When j is 1, I get delta 1 1 in the first term. Let us look at this term. When j is 1, I get 1. So, I get A 1 B 1. When j is 2, delta 1 2 is 0, delta 1 3 is 0. So, the only contribution for the first term that comes is A 1 B 1. Similarly, in the second term, when j is 1, delta 2 1 is 0. When j is 2, delta 2 2 is 0. So, I get A 2 B 2 plus in the last term similarly I get A 3 B 3. So, you can see this is a very compact way of writing a dot product. A more useful symbol is what I am going to define now, I j k. Again I, j and k vary over 1, 2 and 3. This is equal to 1 or minus 1 or equal to 0, depending on how I, j and k combine. So, if I have I, j, k in order 1, 2, 3 or a cyclic order, that means 3, 2, 1 or 1, 3, 2, 1 or 1, 3, 2, then it is going to be 1. If this in the other orders is going to be minus 1 and 0 if any 2 I j or j k or I j are equal. If you find it a little difficult to remember, now let me give you a trick. Let us write, let me take a different color, 1, 2 and 3 in clockwise fashion. And let us also write this in counterclockwise fashion, 1, 3, 2, traverse this in counterclockwise way. If 1, 2, 3 appear any order of this circle, that means if I have 1, 2, 3 or 2, 3, 1, 2, 3, 1 or 3, 1, 2. Oh, so this was wrong. Then I am going to have epsilon I j k equal to 1. If I have on the other hand 1, 3, 2 or 2, 1, 3 or 3, 2, 1, then I am going to have epsilon I j k equals minus 1 and epsilon 1, 1 j is 0 no matter what j is, epsilon 1 j 2 is 0 and so on. So, you can see very easily that there is a very easy way of remembering it. You put 1, 2, 3 if you are going clockwise, put it like a clock 1, 2 and 3 If you are going clockwise, any combination 1 2 3 3 2 or 3 1 2 or 2 3 1 gives you epsilon I j k equal to 1, and any counterclockwise combination 1 3 2, 2 1 3 or 3 2 1 gives you minus 1 and rest 0. So, now I am going to express the cross product. If I take A cross B, its ith component, I could be 1, that is x component, I could be 2, that is y component, I could be 3, that is z component, is going to be expressed as summation over j and k epsilon I j k a j b k, where j equals 1, 2 or 3. So, I am going to sum over 1, 2 and 3, and k also equals 1, 2 or 3. Let us see that. Let us calculate A cross B component 1. That means, I am going to calculate component number x component of this, which is going to be summation j equals 1, 2 and 3, summation k 1, 2 and 3, epsilon I is 1 j k a j b k. Let us expand this. If j is 1, if j is 1, for j equals 1, epsilon 1 1 k is 0. So, j could be either 2 or 3 only. So, I am going to have epsilon 1 2 k summed over k, I have taken j equal to 2, a 2 b k, or j could be 3. So, summation j is 3 and k could be 1, 2 and 3, epsilon 1 3 k a 3 b k. Now, so we have done the sum over j using the fact that epsilon 1 1 k is 0, right. So, now if I look at epsilon 1 2 and k, that is this term, if k is 1, this is 0, because epsilon 1 2 1 is going to be 0. So, the only term that I am left with is 1 2 3 a 2 b 3 plus epsilon again the second term 1 3 k. If k is 1, it is 0, if k is 3, it is 0. So, only choice I have is 1 3 2 a 3 b 2. Now, 1 2 3, let us make again our linear combination 1, the clock 1 2 3. If I go this way, it is 1 1 2 3. If I go this way, it is minus 1. So, epsilon 1 2 3, I am going clockwise. So, it is going to be 1. So, it becomes a 2 b 3. 1 3 2 is the other way. So, that is going to be minus a 3 b 2, which is nothing but a y b z minus a z b y, which is the correct answer. So, you can see by using the symbol, I can very easily express all components in one simple formula like this. And then we are going to use the properties of these to prove various relationships. One property that we are going to use is going to be epsilon I j k epsilon I L m sum over I. That means, if I take epsilon 1 j k epsilon 1 L m plus epsilon 2 j k epsilon 2 L m plus epsilon 3 j k epsilon 3 L m, it is going to be equal to, and I am summing over I. So, I have summed over I delta j L delta k m minus delta j m delta k L. What I have done is, I have taken j and L in the first term and k and m, made their delta symbols, put them here. Then I took the other combination, that is j m and k L, put a minus sign and put the other delta functions. This is a very useful identity. So, let us now see how these definitions or expressing vectors like this